I don't know what to say. All right, here we go. Warm-up is, letter A was factor x cubed, 8x cubed minus 27. Okay, this can be done in one step. What type of factoring, John, is this?
Nothing. Difference of cubes.
Difference of cubes. Okay, so this is like x cubed minus y cubed. John, you're not done yet. What is the general case before I get into this? What's the general equation for difference of cubes? Remember?
X minus y.
Yeah.
And then x squared, x plus xy plus y squared.
Lovely. So this is why we did all this stuff yesterday. Okay, Patrick. What's the x going to be in this case, and what's the y going to be?
I don't know.
Okay. Well, we want something cubed is going to be x, 8x cubed. What's the x going to be? Go ahead. Yeah, so it's going to be basically, it's going to be like 2x cubed. What cubed gives you 27? Yeah. Straight. So in this case, your x is like 2x, and your y is like 3. Does that sort of make sense? Going from there? You guys have seen this before, difference of cubes? Or not? If you haven't, somebody let me know. You guys noticed difference of cubes in your life before yesterday? Okay. It's called learning. This is good then. Okay, lovely. Can someone be brave here then? Michael, we're up to you because I want to get to read next. Michael, can you try and use this equation then? Factor. This turns into what? Go ahead.
2x minus 3.
Yeah.
2x
Okay.
minus 6.
Okay.
Plus 9.
Okay, he is incorrect in 2 spots. Can somebody help him with 2 spots that he's incorrect? Go ahead. Up here. Oh, not that one.
But 36 should be a plus.
This should be a plus 6 for sure, right? Because the equation says plus x squared. Sam, what else? Yeah, 4x squared, because you're squaring this, right? So because x was actually 2x, right? You know what I mean? So if you're squaring that, that's 4x squared. Yes, John?
18 in the middle.
No. No. Because if you're still here, right, you're just doing, all the x, y means is just, your x is this, your y is this, so just 2 times 3 is going to be 6x, right? Good?
Yes.
A little, does this sort of make sense? Okay. What I'm trying to show you is short forms. Okay, that's what I'm trying to show you, or hoping to show you short forms. Okay, letter B. It says sketch that. The question is f of x equals 2x cubed minus 5x squared plus x plus 2. All right. Austin, we're up to you. Were you able to find any roots to that?
One word.
One word? Okay, so f of 1 works. So f of 1 should be 2 times 1 cubed minus 5 times 1 squared plus 1 plus 2. Okay, there are some mean features in advanced functions that make you show all your failures. You don't need to show your failures, only to show your successes. So you need to show me the one that actually works. You don't need to say, I tried -2, I tried -5, I tried 18. Good for you. Okay, I just want to see your final answer. So this is 2 minus 5 plus 1 plus 2. This does actually equal 0. Therefore, x minus 1 is a factor. Do you want to use, what's this, synthetic division? Okay, you guys remind me how to do it because I always forget. Does synthetic division go like this?
Oh, it's this way.
Let me help you here.
Now you put just the numbers.
Okay, now just wait. Now, I'll tell you what gets me confused. I can't remember if you add or subtract. That's what I can't remember. Next, you got it here?
Yeah, well, first, you would just bring the first coefficient, the leading coefficient down.
Okay.
And then you'd multiply that by the 1 on the side.
Okay. Now
Bring
let's
the
do that.
numbers, yeah, there.
Now, do you add these or just subtract these?
You add them.
Because that's what I can never remember. I'm not. This is a serious dilemma. I'm not joking around. -3. If you don't like this method, you want to use long division, do it. I love long division, even though it's long, according to Mr. Lacey. It's accurate. I call it accurate. That's what I call it. Okay. What do I do next then? Nick, you're on fire. Keep going.
We just keep on doing the same thing, basically. Take the -3, multiply it by the 1, and then you add those.
Thank you.
Oh,
Now,
you get 0.
good, very good. Now, Austin, do you answer that? Graham, do you remember this or not really?
No.
Okay, let's give you read. You're in luck. What does that 2, -3, and -2 actually mean?
Well, those are actually the numbers before your x values.
Not at all.
Yeah. Your coefficient.
You thought of your x values? You gotta be a little more accurate. I know. I think I know what
You
you're
have
trying to do.
2x squared minus 3x minus 4.
Thank you. So I need you to spell it. No, I really did. I'm not kidding. In math, if you're not accurate, also, that's really what we're left with. I have to include the x minus 1 there because that's just factored. Dakota, how you feeling about factored quadratics?
Well, it's pretty easy.
Good. Go ahead.
Well, this is a complex.
Trinomial. Yeah.
We have to add, in this case, it multiply to -4 and add to -3.
Good.
And that would just be 4 and -1, or -4 and 1.
-4 and 1.
So you'd have x minus 1 in the bracket 2x squared minus 4x plus 1x minus 2.
Okay, just, I'm gonna interrupt you and come back in a sec. If your grade 10, 11, or 12 teacher showed you a quicker way to factor trinomials, use it. I don't mind. I use decomp. And if you're stuck with me from grade 10, 11, this is how you do it. But if you have a quick way that you, a shortcut. Well, there sort of is. So let me show you the shorter, easier way. I don't like showing this because people don't do it right.
Oh,
I think we learned it very vaguely.
Okay, how did I get that? How did I get that? Well, what I did was the -4 and the 1 came from there, but then I can divide this by 2, so that turns to x minus 2, 2x plus 1. If you don't like that, you don't have to use it.
oh, it's not like.
You can use that if you want to. So just see what I did. The 2x stayed because the 2x came from here, right? And the coefficients -4 and 1, you all divide by 2. If you want to use that method, you can. I like Dakota's method, to be honest, because I taught Dakota before, and that's what each one needs to leave up there. Anyway, it's gone. If you want to see it, the website will be there for you. I'm sorry. I'm too enthusiastic. Okay, so this turns into 2x bracket x minus 2 plus 1 x minus 2, which is f of x equals x minus 1, x minus 2, and 2x plus 1. Have I lost anybody yet in factoring trinomials? Okay, Sam is up. Do you want Sam or Samantha, by the way? Sam. Do you want, oh, sorry, do you want, what do we have, now that I have this, what do I do with it? How does this help me? Yeah, what are my x-intercepts, please? Good. Max, what is my y-intercepts? 2. Now, people said they didn't know how to get it. You can use this if you want to. If you have it in expanded form, just get rid of all the x's. It's 2, right? So my y-intercept is going to be 2. Okay, end behavior. I'm going to start to use a little calculus here. As x goes to infinity, meaning this way, where is y going to go? Goes to positive infinity. You guys seen this notation before? Everyone seen this? Yes? Okay, as x approaches negative infinity, y then also will go to? Thank you, negative infinity. Okay? Feeling okay? We go our x-intercepts, we go y-intercepts, we go our end behavior. Alright? End behavior, oh sorry. How do you get the end behavior? So remember, this is like the dance, the function dance. Did you guys do the function dance? You hated it probably, okay. If something is an even function, this is like, you're looking at the leading power. So an even function would be x, will look like x squared. So a positive even function will then behave like this.
It's just that based on.
Right on. And then the same thing for odd, looks like a linear. That will be x, x cubed, x fifth. But there'll be different stuff that happens in the middle, right? But as far as just the end, so far as that. Okay. Lovely. Okay. don't have your name written down here. Robert? I can't remember. I'm sorry, Robert. Okay, what's that again? Robert, how do I graph this?
Well, you have the x-intercept, so you can plot those out into y-intercept.
Okay, y-intercepts, x-intercept. Sounds good to me. I'm going to do this on graph paper because that's how I roll, as the kids say.
Is that what the kids say?
They do actually say that. I have a kid, so I know that's what she says. Okay, so here's my lovely graph when we're getting up to just 2 this nice small graph. So when I do that,
It's good enough, don't worry.
you get an X going to see this. So what if the Ontario Federation of Math Teachers comes and comes to us here? They do exist. Okay, so I'm going to put on the interesting information here. Please be accurate with your graphs when you're doing something formal. Just to be neat, why did I choose that scale that I used right there? Somebody please tell me. This is back to grade 9 again. Yes? Why else? So if you look at my x values, what do I look at my x values? Good. Why else? There's a half in there, so I'm going to put every square as 1/2 just to be accurate. Okay. And again, it is to make it big there too. I taught a lot of you guys grade 10 when we did this all in the first case. Okay.
I have a question.
Yes.
I graphed it, but will you?
You're being the computer again. Or you?
No, I'm just wondering.
Okay, good.
I know, I sketched it.
Good.
It's a sketch.
Good. Okay.
Well, actually, my question was
Anyway.
when it happens.
Okay. So what I'm going to do, I'm going to draw my roots here, and then I'm going to ask a question. So it's going to be -1/2. It's right here. 2 is going to be right here. What else do we have? 1 is going to be here, and 2 is going to be here. Has my your question happened yet?
Nope.
Okay. End behavior I'm going to do next, because you can do test points, you can do all sorts of things with end behavior. Courtney, what is the end behavior going to tell me? Or how does I use that to graph this?
You know that from the -1/2 goes down.
Okay, so that's all you know. Now, if you wanted to do test points, you could get an accurate graph. Okay, right? But we're looking for slope and things like that in this course. That's what you know. Did your question come up yet?
Nope.
Okay, Nick, what do I do now?
Well, basically, you just connect the lines to the y-intercepts and the x-intercepts.
Okay, here's my question.
Good.
How far deep between the 1 and the 2, that parabola, how do you know where to?
Calculus.
Oh,
The other thing you learn in calculus is if the graph looks like this, and there's no roots, how do you actually graph that? In advanced function, you couldn't graph something with 1 root, right? Or the same thing with advanced functions. Let's say you had a graph that looked like this, but there were no zeros. How would you graph that? In advanced functions, you could not actually graph that graph.
can you do it in calculus?
Oh, you certainly can.
Oh, my dreams are coming true.
That's good.
You know how long I've been wanting to graph one of those?
I know, I can imagine. Okay, there's your graph. Good. Now, if somebody was asking me, I'm going to hit pause here so I don't have to tell my story in front of the internet. 13 minutes.